In our previous video, we started with matrix multiplication. That's when we multiply a matrix by another matrix. And then we started with the order of 2 by 2 matrix. 2 by 2 matrix. All right. So we know that when we want to evaluate for the first column, okay, we are going to multiply the first row of A by the first column of B. And when we want to evaluate the first row, second column of the result, we are going to multiply the first row of A by the second column of B, and the same continues for first row, second row, first column, and likewise second row, second column. Now, before the end of the last video, we gave an example that we should multiply matrix A and B together, and notice that two of them are a 2 by 2 matrix. All right, so let's proceed with this now. What is A multiplied by B? So we want to evaluate the first row and first column, so we'll multiply the first row of A by the first column of B. So this will give us 3 multiplied by 4 plus 1 multiplied by 3. And likewise, we want to evaluate the first row, second column. So we are going to say that, oh yes, we take the first row of A and the first column of B. So this will be 3 multiplied by 1 and plus 1 multiplied by 2. In the same vein, we want to evaluate the second row, first column. So that's the second row of A multiplied by the first column of B. So that's 2 multiplied by 4 plus 1 multiplied by 3. And finally, this is the second row and the second column. So that's the second row of A multiplied by the second column of B. So that's 2 multiplied by 1 plus 1 multiplied by 2. So we have our final result of AB to be 12, okay, plus 3, that's 15, 3 plus 2, that's 5, 2 and 4, that's 8, plus 3, 11, 2 plus 2, and that is 4. So we can see now that matrix is basically the row multiplied by the column operation. All right, now we have been dealing with 2 by 2 matrix multiplied by a 2 by 2 matrix. Now, what if it is a 2 by 3 matrix multiplied by a 2 by 3 matrix? Will it work? Let's take an example, or let's use an illustration. Let's say this is A and this is B. So we have A to be a 2 by 2 matrix. So let's say it is A11, A12, A13, and A21, A22, A23. And we have B, which is also a 2 by 3 matrix. That's B21 multiplied by B22. No? It should be B11, B12, B13, B21, B22, and B23. Now, of course, when we did a 2 by 3 matrix, a 2 by 2 matrix, we had 4 elements as the result, which is a 2 by 2 matrix. So here we should be expecting probably a 3 by 3 matrix, right? Or sorry, a 2 by 2 matrix. So let's proceed with the results. So when we want to evaluate the first row, okay, and the first column of the result, so that will say we multiply the first row of A multiplied by the first column of B. Let me repeat that. So we want to evaluate the first row, first column. So we are saying we multiply the first row of A by the first column of B. So this is A11 multiplied by B11 plus A12 multiplied by B21 plus A13 multiplied by what? So we can see there is an error here now. So this are 3 elements, these are just 2 elements, so definitely it's not possible. So not possible. So that means we have a 2 by 3 matrix multiplied by a 2 by 3 matrix. Again, is not possible. However, if we have another element here, if we call that element B23, right, let's use a blue pen, B23, yes, then it will be possible such that this will now be B23, sorry, B31 rather. So this brings us to the rule of matrix multiplication. The rule of matrix multiplication says that the column of A, the number of column of A must be equal to the number of rows of B. Now we can see now that the column number of A here was 3 and the row number of B here was 2. So it was not possible. And then we saw that if there was an additional number of row of B making this 3, it will have been possible. Okay, now this is the principle behind matrix multiplication. So when we add a 2 by 2 matrix multiplied by a 2 by 2 matrix, we can see that this is possible. And likewise, when we add a 2 by 3 matrix multiplied by a 2 by 3 matrix, we can see this is not possible. It's possible because the column number of A is equal to the row number of B, and not possible because the column number of A is not equal to the row number of B. So we can see that these two must tally. So look at this now. 1 by 3, is it possible for 1 by 3 matrix to be multiplied by a 2 by 3 matrix? Is it also possible for a 3 by 1 matrix to multiply by a 1 by 3 matrix? Or is it possible for a 3 by 4 matrix to be multiplied by a 2 by 2 matrix? Now, yes, what are your answers? 3 by 2 matrix, this does not tally, not possible. This tallies, yeah, possible. This does not tally, so definitely not possible. Now, if all these things are now possible, we have 1 by 3 matrix or 3 by 1 matrix multiplied by 1 by 3 matrix. We have a 2 by 2 matrix multiplied by a 2 by 2 matrix. And what then will be the result? Okay, what is the order or dimension of the result? Now, in the previous video where we had A, which is a 2 by 2 matrix, multiplied by a B, which is a 2 by 2 matrix. So we have 2 by 2 multiplied by 2 by 2. All right, and then we said it is possible because this is possible. Now, therefore, the result now will be what? A 2 by 2 matrix. All right, now let's take again. If we have A to be a 2 by 3 matrix and B to be a 2 by 3 matrix, therefore we have a 2 by 3 multiplied by a 2 by 3. It's not possible. So let's say this is now a 3 by 3 matrix. So yes, now it is possible, right? So now the result will be what? We are taking the last extreme, a 2 by 3 matrix. Yeah, it's quite fun. And let's take another theorem. Let's say we have a 1 by 3 matrix and we have a B, which is also a 3 by 1 matrix. So we have 1 by 3 multiplied by a 3 by 1. What will be the results? Yes, it's possible, right? Then the results now will be a 1 by 1 matrix. So therefore, we have the rule that states that if we have M by N, which is matrix A, let's call this matrix A, and then we have is being multiplied by let's use this, okay, is being multiplied by a n by k matrix. Now we know that it is possible, okay, because this which stands as A, this is A, and this is B. We know that it is possible because the column number of A is equal to the row number of B. Therefore, the result will be a M by K matrix. This will be the result. So therefore, if we have M by N being multiplied by a N by K matrix, the result will be a M by K matrix.